Welcome everyone. In this video we are going to be exploring how to use the distance formula to help us find the distance between 2 points on a XY coordinate plane. Okay, so first before we get into specifics, let's read this definition of the distance formula. So the distance d between any 2 points with coordinates x1, y1, and x2, y2 is given by this formula right here, which is d equals the square root of the difference of the x's squared plus the difference of the y squared. So now let's look at this image on the right. I think that pictures, at least they help me visualize what the words in math mean. So I think this picture over here will help you kind of simplify this definition so you know what's going on. So we have point 1 here, and we have a second point here. So the distance formula helps us find the distance of the line that connects the points, and we label that with the letter D for distance. So the distance formula actually comes from the Pythagorean theorem. So if we kind of think about dropping this vertical line and extending this horizontal line till they meet, they form a right angle, and you can see that those lines form a right triangle where we would use the Pythagorean theorem. Okay, so let's explore that a little farther. So the distance formula actually comes from the Pythagorean theorem. So before we get started, let me write the Pythagorean theorem up here. A squared plus b squared is equal to c squared. So if we look at this image on the left, we have our point 1 and our point 2. And the distance that we're wanting to find is that line between them, the straight line between them, which we label as D. Okay, they already, in this image, there's already the lines here to form that right triangle. So if we were approaching this kind of with the Pythagorean theorem mindset, we would label one of the legs A and one of the legs B for the right triangle. However, when solving these formulas and using the distance formula, we're only given these 2 points here. We're only given that A and the B points. We're not given the sides of the A or the leg B. We're not given that length like we have in the past when finding the missing leg with the Pythagorean theorem. So we have to kind of get creative of how we know what that distance length is. So recall from a couple units ago when we learned about slope. So slope is the difference of the y's over the differences of the x's. Okay, so let's turn our attention back up to this picture. So we see that A is a horizontal line, and we can view A as the difference of 2 x points. So if we kind of look, here's an x point with an x value, and here's a point with an x value. So we can see that A is the difference between those 2 x points. Okay, the 2 x values, the ending in the first one we can subtract. Okay, so A is the change in x in this situation. Now B, since it's a vertical line, it's looking at the change in y. So B is our y2 minus our y1. So now we have our A and our B values in terms of our points. Okay, so now we're going to substitute this into our Pythagorean theorem so we can get to the distance formula. So A, we said, was x2 minus x1 quantity squared, plus B is our y2 minus y1 quantity squared. And since here we are looking for the distance, it's still the hypotenuse, but since we're looking for the distance between 2 points in a slightly different context, let's go ahead and substitute D in for our C. Okay, so we're very close to the distance formula. If we scroll back up to C, so now all we do, we have the change in x squared, and we have the change in y points squared. So now we just need to take the square root of both sides to arrive at the distance formula. So take the square root. So now on the left side, we have the square root of x2 minus x1 squared plus y2 minus y1 quantity squared is equal to d. Okay, so in conclusion, what we just showed here is that by starting at this Pythagorean theorem idea, we can get to the distance formula. Okay, so now let's do this an example of actually using the distance formula to help us find the distance. So like I encouraged you all with the Pythagorean theorem, go ahead and write your distance formula to start with, so you know exactly what points you need to find to fill in. Okay, so I have my change in the x's squared plus my change in the y's squared. I'm going to extend that square root just a little more. Okay, so now let's look at my points. It doesn't matter what point you make your first point and what makes your second point. So I'm just going to do this one as my first point of x1, y1, and this 5, 2 as my x2, y2 point. Okay, we'd still get the same answer if you decided you wanted the negative 3, 4 to be your x2, y2 and your 5, 2 to be your x1, y1. You'd still arrive at the same solution, so you can do it either way. Okay, so from here we see that our x1 is equal to negative 3. Our y1 is equal to 4. Okay, I just paired these up right here. My x1 is negative 3, my y1 is 4. Now my x2 is equal to 5, and my y2 is equal to 2. So now I have those numbered, and so I can just plug them into the distance formula. So x2 is 5, x1 is negative 3, so put that in parentheses since that negative is with it. You have to be careful with adding and subtracting your integers here. So plus y2 is 2 and y1 was 4 squared. Okay, so now let's apply order of operations. We got to simplify what's inside before we can take the square root. So 5 minus a negative number is the same as keep, change the sign. So 5 plus 3 is 8 squared, plus 2 minus 4 is negative 2, and that's squared. Okay, we just have a little bit more simplifying to do before we can take the square root. So 8 squared is 64, plus negative 2 squared is 4. So the inside looks like it becomes 64 plus 4 is 68. Now this is not a perfect square, but we want to try and simplify the square root as much as possible by pulling a perfect square out. So 68 is divisible by 4. So this becomes the square root of 4 times the square root of 17, because 4 times 17 gives me that 68. So the distance, the square root of 4 is 2 root 17. So my distance of this line between those 2 points is equal to 2 root 17. So we were given slightly different information. We were given 2 points this time on a coordinate plane, and we can use a slightly modified version of the Pythagorean theorem to help us still find that length of that line, which is the distance. And so we did that in this case.